All right. Well, good afternoon, good morning, good evening. Not good night yet to everybody out there in television land. Thanks for joining us on day 4 of the J Champions Conference. So I am delighted to be moderating for what I'm going to characterize as 1/3 of the InfoQ Java team here. So it's myself, Bazlor, and Shaf. They all write for InfoQ on the Java space. So I'm very happy to be doing that. And without further ado, I'll let the two of them introduce themselves and get going.
All right. Maybe I can start with myself. I'm Bozlur. Yeah, so that's my name. I love Java, and I'm trying to learn LLMs nowadays. Obviously, my teacher is here, Shaf. I'm learning a lot from him. So today's, I would say, star of the show is him. So I'm gonna learn a lot from him and cheer for him. So that's the whole idea. All right, Shaf, do you want to introduce yourself?
Yeah, sure. You didn't say all those nice things before. It feels like I'm gonna run the whole thing now. So, so my name is Syed Shaf. I work at Red Hat as a senior principal developer advocate. I work with Java. I've worked with Java for many years. And these days I've been working with large language models, tuning them, doing applications, etc. So interesting things that both of us can share with you, what we've been cooking along, playing with, and what we have learned, and hopefully it will help you as well. Our talk is going to be based on Jakarta EE and LangChain4j, so you will probably see some of those demos. Well, you see a lot of demos. Hopefully we'll get to that. But first, before we do that, we're going to just move on to a little bit of slides and go put some introduction for those of you who might not know large language models. So hopefully it'll be interesting, and then we kick in the demos. So if you look at large language models in general, you heard GPT. So if I ask anybody, hey, do you know about large language model? And they'll say, oh yeah, there's ChatGPT, but there's a lot of large language models, right? And it came out of this paper from Google about transformers. But interestingly enough, it gives us answers in natural language. And one thing that is not common with systems is that actually a lot of systems, or most of the systems, do not speak natural language. They can't translate. They lack context. They out of their system boundaries. So if a system is specific to a certain situation, it stays within that certain situation. To integrate data, you need to kind of mix those systems together, create another fun abstraction on top of it, right? So things are not so simple when we talk about unstructured data, getting that information out, and generating more content out of that important information. So me as a developer, I write, let's say, I create a database model, I put an application on top of it, and every time I need to make something new out of that data, I need to either create a report or I need to create a view or something like that. So it's hard to actually create that content that sits on top of the data within the applications as well. And another fact is that the data is growing rapidly. So it's not just within that system, but it's growing all around us from all kinds of endpoints and events, etc. We're getting this information, and how do we actually can correlate that information, create that into a pipeline that could actually help us. So there are those rising challenges and expectations, mostly from customers. Like recently, I know someone who had some internet issues, and when they were not able to get them fixed through the normal processes, because the normal processes were so rigid, the expectation obviously is that things can be done instantly, things can be done in a more simplified manner, and natural language processing somehow gives that power. I'm not saying it's an all-in-all answer. I even have my own reservations how that would work, but it does seem like there's a lot of things that you could fix with just doing the natural language processing. And hopefully during this talk, we're going to give you some ideas and talk about how you can actually embed such things within your application. Then finally, obviously, the skills gap. The expertise are limited, and AI adoption. We're talking about AI. You hear all the words about AI. Even if another company brings a new large language model, the stock market starts to go down. So it's become extremely important for us to learn artificial intelligence and its applications. And I would rather say machine learning, right? So that's the context. Furthermore, I mean, systems, and I think I kind of touched upon that, they're more rule-based. They struggle with real-time data and the awareness of the context that pens those decisions forward. And that from when we look at large language models and their ability to do transformation or natural language, it sort of feels like it's a miss. Why can't we actually use this, and why can't we actually benefit from it, right? So before I go forward, I mean, some of you might know large language models, but I'll just quickly go over a bit. It's also going to give you a bit of my age here. But anyways, you know, when I was in university, I was working, one of my courses was expert systems. So that's purely on the left. And back then they were like not so interesting, to be honest. They were nice. They were really hard to work with, you know, the use of data, you know, manually authored rules. It's extremely brittle, to be honest. It wasn't very simplified in a way, or the approach of collecting data and creating sense of it was very hard to engineer. But then, you know, further down the line, you see that out of that evolution, machine learning, labor intensive data, you know, data prep, you know, pre-processing, ETL, all these different techniques came in to actually help that. And you could have some sort of machine learning algorithms that could do certain use cases, etc. But it was still very laborious until actually came deep learning. That was somewhere around the 2000s, late 2000s, where we started to look at supervised learning and unsupervised learning. Now, everything on the left was very much specific to how, as a developer, as a programmer, you define or design things, and the knowledge was very much construed to the fact that whatever the boundaries you put in, it would just stay within that boundaries. That is somewhat true, but the increase in data would put you in a lot of pressure around how you would work with these. With deep learning, we went into supervised learning and unsupervised learning, and here examples like classification, you know, is an email a spam, as an example, is one of the examples of classification, but also is dog a cat or a bird or duck, are they the same, etc., etc. All these different things you could actually do with deep learning, and create your, you know, tensors and neural networks that would increase this knowledge as you go ahead. But most recently, foundational models, which was coined a term by one of the Stanford papers, I believe somewhere around 2011, is you know, learning without the labels and adaptive, this massive data that you can put through within layers and actually create something that uses natural language processing. And that is where we are today with large language models. There's a lot of data that is out there that has been used in all these large language models. But most importantly, what are the use cases that a large language model, or Gen AI as we say it, you know, can do today? They can do translation. So that's pretty much from the paper, attention is all you need, transformer architecture that Google actually put out. Large language models are mostly trained on billions of words, right? So there's a lot of words that goes in there. There's a lot of pre-processing of data that goes in there. Those words are then layered upon layered across each different context, etc. So all of that training process, which we Java developers do not look at, and nicely so, I think we shouldn't even look too much into it. It is another engineering field by itself, right? But what is the tasks that we can ask a large language model in the most simplified way? We can ask for translations, we can ask for summarizations, we can ask for writing question and answers, and solving some of those problems as well, right? But this is not it. You know, there are foundational models, there are created large language models. So foundational models are more broader in the sense, whereas large language models are more sort of in the natural language processing area. And what basically a large language model is doing is, based on all these billions of words, it is actually predicting tokens, and statistical deduction is being done on this on your queries and the data set that is there to actually ensure that we get the right answer from them. So let's take a look at tokens, and you might have heard this word a lot, right? Tokens, and max tokens, and hey, I'm on a free API, and I have this problem sometimes that you get out of tokens, right? And that is the limitation of a large language model, but also the way large language model works, right? the limitation in terms of context, we cannot send an entire Java project with millions of lines of code into a large language model because it cannot handle all those tokens. So what are these tokens? Tokenization is purely a technique on how specific words are broken down, and there are multiple algorithms to do that. And there's a very nice book called Building Large Language Models from Scratch by Sebastian Raschka. And I think it's a very good book that if you want to delve into the details of how to build a large language model and what goes under it, I would highly recommend that. This is not marketing for him. I just like his book. I read it, and I thought it was useful for all of us to know about this. Tokenization, if you look at tokenization, one concept, you have many words and billions of words that are there. How do you actually break them so that you can actually make sense of them from an algorithmic standpoint as well, right? So that's how you create embeddings out of that. And those embeddings form this mathematical relationship between those different words. So for example, there is an algorithm called word-based tokenization. So that has the full word, like you see running, and unpredictability. But then you have a subword algorithm that a lot of large language models use, is actually the running becomes into 2 tokens and unpredictability becomes into 3 tokens. So sometimes some of you might have ran an application and say, why are there so many tokens that are more than what I've actually asked for? And that is the reason, because the token and the algorithm for that is used can actually tell you exactly how many specifically tokens that you're going to use. So it's a good understanding to have. There's another algorithm called byte pair encoding. So if you want to go into more details, you feel free to get into the book and go through some exercises there. Yeah, so large language model, awesome, very technical, interesting, but they make a lot of mistakes, right? Like this nice person who has all the fingers on their hands, right, according to the large language model. So generation is statistical. It feels like it might be true, it might be accurate, but what's really happening is prediction of tokens in the backend. So you're taking what's there and you are basically predicting statistically based on the temperature. Things can convert totally differently. So you have temperature, min and max, and that kind of sets up how deterministic or non-deterministic the large language model's response would be. So one thing when we craft systems, it's extremely important for us to keep in mind is that large language models will make mistakes, and we need to be there to see how they are. And that also means that I would not most likely use a large language model in a mission critical system. I'm not going to use large language model for healthcare where somebody needs specific care or medicine, because if there were problems and it's not well tested, I'm going to have serious problems and life could be threatened, as an example as well. Truth is discrete, it's not continuous, pretty much similar. The statement pretty much means that, let's say you have image processing, you have mean squared errors. All it's doing is actually statistically determining what is the next token. And based on your settings and how you set up your large language model and how you work with it, you could get various results. And you could ask the same question twice in 2 different sessions, and you might get 2 different answers, right? And that is because it has the statistics element to it. So it's not like, hey, a doctor saved 6.5 people's life. It is a doctor saves 6 people's lives. So truth is specifically discrete. And we need to understand when we develop solutions or software that it's not continuous, and whereas large language models or AI in that sense is a lot more continuous. So that's one distinction we should definitely keep in mind. And this is meant to scare you, basically. So there's a lot of words out there, and you hear about tokens, transformation, embeddings, hallucinations, guardrails, and all of these different things that exist there. And obviously, they are a lot to handle and think about. And when I started to study into large language models, I was totally bummed. I was like, what's going on? What is all this? What do I learn? How do I go? So hopefully within this talk, we're going to give you some basic, the rule set or guidelines, or maybe some tips or tutorials that you can look into exactly how you can formulate your journey into learning large language models as well. So LLM offers a scalable, adaptive way forward. Let's see how Java and JakartaEE simplify this journey, right? So for what we are presenting today is we take all those entire concepts and we say, hey, why cannot Java developers use large language models anywhere? I speak to some of the people developing in Python or some of those other libraries, or even some Java developers, and there's like, oh, AI, we don't do AI in Java. No, we do AI in Java. We specifically do large language models with Java, and we can make them extremely awesome to do it. So if there are projects like JLlama that can actually host large language models, there are projects like LangChain4j that can really offer us a lot of guidelines into how we can work with large language models. So you do not need to change your language. You can still use the same frameworks. You can use JakartaEE. You can use LangChain4j, and LangChain4j comes with not just JakartaEE, but you can also use it with Quarkus or Spring or whichever framework you love. But we chose JakartaEE for this journey. So I mentioned or dropped this word LangChain4j. What is LangChain4j? Initially inspired by the LangChain project in Python, but really it is not just what LangChain does. It does a lot more. It has a lot more areas around it. And if you're looking at a tool or a framework to work with large language models, you should look at LangChain4j, and that's specifically for us Java developers. That gives us a lot. It gives us tools where you can do LLM integration, so you don't need to think about, hey, I'm using large language model. I only need to use OpenAI. No, you can use almost any large language model out there. You can have self-hosted large language models. You can work with DeepSeek if you needed to, etc. All those different models you can work with. And it is obviously for Java developers. It has a lot of interesting APIs around, doing prompting, and we will get into that in our demo, but also with RAG, enhancing the LLM experience, how you do document processing, how you add those documents to your large language model so you can have a better context, because large language models are trained on public data. There is some data that you might want to use that is your private data that does not exist online. So how do you enhance that request? And that's where RAG comes into there as well. And it's nice modular architecture, etc. The second one, obviously, we're using JakartaEE. JakartaEE is an important part of our ecosystem. It has a lot of history to it. Tools like Wildfly, Peara, Glassfish, JBoss CAP, WebSpray, there's tons of them that use JakartaEE APIs, and it is something that we all have experienced at some point in time. So if I look into it from a perspective of a lot of applications that are out there, a lot of Java applications out there, it makes a lot of sense to combine JakartaEE together with LangChain4j to have a large language model experience as well. This is not to say that this is the direction of JakartaEE. They might choose multiple different variations of frameworks, but in our opinionated talk today, we talk about LangChain4j and JakartaEE. So here we are. I can jump into demos. If there's any questions I could take at this point as well, would love to take them. Nope.
Yeah, there's nothing at the moment. There was just some discussion about the number of R's in strawberry, and that was asked by Simon, and then Johan said there's R2 according to ChatGPT. So.
Yeah,
but other than that, yeah. And then Baslor, you said that DeepSeek was able to answer that correctly. So that's where we are.
Nice. Well, I didn't ask that question, so Baslor, thanks for doing that. I mean, yes. So truth is no longer discrete anymore, right? So it depends on which large language model you use. Well, okay, cool. So what I'll do is I'll head into a little bit of demo. I'm going to show you some of the stuff that we've been working on. What here I have is, let me just summarize this. We have a project repo called LLM Jakarta, and we're going to share that with you after the talk at the end as well. And we've created some basic guidelines around steps around from 0 to 6, and sort of as we were learning together, me and Baslor, getting into this and doing all the fun stuff, we said, okay, how about we have some steps? And I think mostly Baslor started to look into it because I was already doing something else at that point. And then we're like, okay, what would be beneficial for everyone to look at, right? So I'll start with the most basic step here, and then at some point I'm gonna try to pass on to Basler if I don't eat up all his time here today. So we have this project where basically we have a chat WebSocket implementation, right? So nothing super serious, very, very simple. It's a WebSocket that runs on our application. So we have a nice chatbot UI, which I'll show you in a second. And we work with that, right? So very, very simple. But what we do have is we're using microprofile config, and in our microprofile config, we have multiple properties that we have set through. So let me just go over a little bit about those properties. So we're using GPT-4o as a model. We set the temperature at 0.7, which relatively means that it's a little bit non-deterministic. So it has some randomness into it. If I was to set this to 0.0, it would mean that it would be fully deterministic. Now, that would mean that whatever the large language model has, it's going to try to be as deterministic as possible. Whereas when you go higher, 1, for example, that is, you're telling it to be more creative, and yes, then the fingers on the hands can be removed, as an example, right? So stuff like that can start to happen. There's also other things around timeouts, but I think most importantly, what people might struggle with is max tokens. If you're using, let's say in our case, like we're using OpenAI, you might struggle with tokens if you're on a free tier, but if you're on a paid tier, you might not struggle with tokens, right? So that's the words, etc., that I spoke about earlier. Then we have a simple LangChain service. What we do here is that we create a chat model. We put all those config parameters in there. We call the build method, and very simply we call the send method here, right? So what I'll do is that I'm just going to jump on to my step 0, and then I'm just going to run Wildfly, and we are using Wildfly to deploy this. And what it should do is that it should bring up the server, and I'm just going to do that. Yes, perfect. It does bring up the server, so very nice. And then I could ask questions about what is Java as an example, or what is, okay, that's taking a bit longer. That usually doesn't. Hang on. Okay, we see some response coming. And then it goes into this detail about, Java is a high-level language, etc., etc. But this is very, very simple. Now, if I ask it, for example, the same question again, you'll see that it was waiting for a long time, and it was bringing all this data at once, right? And we don't want that. What we want is basically ensuring that we can also stream something like that. So very, very simple chatbot here. What we've done is basically simple HTMX, chat window, backend sends questions to the large language model. Streaming is also an option, right? So how do we go into streaming? So let's go next into seeing how we can do something like streaming. So let me do that.
Can we ask the question? Simon really wanted to know what the latest version of Java. Can you ask that to our chatbot?
Okay, I think this is going to be a very interesting session today. So let me do that. I'm going to bring another chatbot up, and just give me 1 second here. I did not run, but I did tell Mike that my cat might just ask me to go out. So sorry about that. Things happen. And here again, I'm going to, put the second version of the chatbot here. And let's ask, what is the latest version of Java? Okay. So you're just mixing into my demo here. So the old age question, what is the latest version of Java? It's like asking a magician how he pulls a rabbit out of his hat. Always changing and oh so mysterious. As of now, we're graced with Java 21. Okay, so you're correct. The latest version of Java, it doesn't know, right? It doesn't know where the data is, etc. So what happened here is actually I have created a prompt, right? So and a prompt is something that I would send in. But you also saw that while the answer was coming in, so if I ask something again, what is a singleton, you'll see that it will start to stream the answers as it speaks. In the previous example, it wasn't doing that, right? So that's the very basic thing, a very simple hurdle that you cross on. LangChain4j provides you the possibility to get the streaming as well. So you're able to do that. But, fun stuff. The singleton pattern, just what every caffeinated developer dreams of. It's like VIP section of design patterns, right? So stuff like that. And by the way, while I go into some of the details of why it's doing this and how it's doing this, please feel free to put a question. And I think I do have a question here which says, will the New York, well, that's not a Java question, but let's see. Will the New York Mets win the World Series this year? The New York Mets and the World Series, two things that seem to be in a committed relationship with disappointment. So, anyway, so I'm not a follower of this, but you need to ask a Java question, and that's what this is trained for. So let's do that. So let's take a look at what's going on. Basically, what happened was that I've designed certain prompts, and those prompts behave in a certain way. So let me take you to the Java code, and we're going to have some more fun with this, hopefully. If I go in my source folder, what I've done is basically we've created some prompts here, right? And a prompt is basically a personality that we have given. Specifically, prompt is not really a personality, but what we do is that we sort of like just take a specific text from this, right? But what LangChain4j gives us. So here, this is obviously we're using LangChain4j and using the token stream. But what LangChain4j is really giving us is the opportunity to basically say, hey, you can provide a system prompt, and every time the request is going to go in, I'm going to enhance your request with your system prompt. So here, the system prompt for us for this specific scenario, which is the Java champion scenario, and the class called Java champion, is a sarcastic Java champion with a witty, sarcastic, humorous tone. Use case for users who enjoy a bit of humor. So basically what it's answering in this is actually answering with some humor. And in that humor, there's some sarcasticness, right? So I do live in somewhere up in the north. So this is very normal for us to have a bit of sarcastic humor. So I put in there, I hope it doesn't hurt anybody's feelings. But then what we also do is that we add user prompts. And this is, again, something LangChain4j gives us, is the system message and the user message. And in the user message, I can ask LangChain4j to, give me a certain specific way of how the user prompt is structured. So when I say, what is a singleton, what LangChain4j does is respond about topic, which will be, what is a singleton? All will respond at the end with, I am the real champion. So all the answers are always filled with, I'm the real champion, right? And what's happening here is simple passing of parameters. Get user text, gets the text, and LangChain4j goes about and does its specific business, right? So let's say if I go back here and I say, okay, I need to refresh. Since I have a 5-minute timeout, I think I spoke more than 5 minutes. That's a good thing. Tells me that as well. So if I say something like, hey, do I really need to write binary search in Java? And what it does is say, oh, absolutely not. Who needs efficient search algorithms when you can just sift through an unsorted list like it's a fun treasure hunt, right? Obviously, that's gonna be extremely interesting if we do that. So what we've done is, by crafting the system prompt, we've actually sort of tailored the way the chatbot actually is working with large language model, and with the help of LangChain4j, we are able to basically do that, right? So it kind of helps us. What you do with a system prompt is extremely important. You should define the task at hand. You should set the expectations. So in our case, the expectations is very straightforward. It's sarcastic, it's humor, it's non-serious in a way. And then obviously you want to sometimes also provide examples as well. And we'll get into that in a bit too. The second thing obviously is the user prompt. Again, you differentiate between the system prompt, which gives it a specific flavor across all the questions that are going to be asked. whereas the user prompt is the one that kind of defines how that would respond to each user based on that specific input that they do. They both kind of correlate to each other, but you could see a system prompt being the more like a root level in a sense that it gives this, the rules and the framework how you should do it. So a good example about rules and frameworks, if I go in, for example, into what we've done basically, if you saw here that we use sealed classes here, non-sealed classes, and we extend from personality so we can actually switch between personalities. And here, if you look at it, we have a couple of them. So if I change my personality to something like chain of thought, and then press save, and hopefully this will work and nothing breaks. So what it will do is that it will change the personality, right? So now if I ask questions like, hey, what is the ethical reasoning of X and Y, it's going to go back in and start to think, and it's going to give you a much more detailed answer about chain of thought reasoning. And what chain of thought reasoning is basically going through a hierarchical process of doing things step by step. If I go back into my prompt again and just show you what I'm doing with chain of thought here is I'm saying you're a helpful assistant, always provide concise and professional responses. When solving problems, always explain using COT. If I was to just change this to TOT as an example, what would then happen is that this is going to go into what we call not train of thought, but basically translation and action, etc. So let me just do this again. Since I restarted the server, the WebSocket died. So here you say, hello, I'm an assistant. Any questions of information you need help? So let's ask something about maybe the question that Mike was asking was Mets. Yeah. So why do Mets? Is that Mets? I have no understanding of baseball. So let's say always lose. I hope I don't offend anyone. So anyways, so to understand why Mets may struggle to win consistently, it goes into topic, observations, and takeaway, right? So that's how we have structured our prompt, that all our output is going to look like this. So there's a lot that you can play with. Now, if I asked it to give me, let's just do like this. If I ask something like, the same question, famous question or infamous question now, give me the response in JSON. This actually might even break something, but let's see. So it's going to give me a JSON response, but the JSON response might not always be correct. And that's the most important point here, because it is a chat model, and there are different types of chat models. There's in large language model, you have instruct models, you have code models, etc. So you want to be able to put the right request to the right model, right? So a lot of times this might not actually work, but here it kind of works in that sense. If I go back here, so what is a good prompt? Structure your input, know your output, and you will have to work through it. It's never going to stay the same. If the large language model is updated to a newer version, you will see a different response. You might see that you might crafted an awesome prompt, but it did not behave the way you wanted to do, or somebody asked a very different question and it no longer behaved the way it did, right? So try. You will have to keep on coming to that conclusion that you have to keep on tweaking the prompts. The most important thing, I think, or one of the most important things which people forget is that, hey, I used this prompt against OpenAI, but now I'm going to use this against DeepSeek because it gives me this OpenAI implementation of the API. Very nice, but the prompt answer might just be totally different. And that is because do not try to migrate prompts across models. It is a pain, and it's going to give you a lot of pain if you do that as well. I showed you chain of thought, TOT reasoning, and then there was also tree of thought, where you can go into basically the entire different models or different types of thought. So you can go into those kinds of aspects. Now, they might not be on a chat model basis, but they might be in terms of chaining your prompts, having multiple prompts and passing information around it. You might go into other things which Basur would basically touch on, where you might need things like this that would actually give you in research, etc., and so on and so forth. So at this point, I am going to stop, and I hope you enjoyed the fun as well as the talk as much as it is, and keep on asking questions. I'm going to go in silent mode, and Basler is going to take over, and we're going to take it from there. So over to you, Basler.
So, yeah, we do have,
sure,
while we're switching, we do have one quick question from Vincent. The chat box is quite fast. How do you manage that?
Oh, that's a good question. Well, I don't know, Vincent. It's to be fair, it's maybe it's a good day. It's on open. We're using OpenAI. We're using GPT-4o. I have a paid version for it, but it could just be that I'm getting good responses. It does respond fast. If I was using it on my local machine, I would expect some more latency too because of resources. So I guess I can say it's at this point is OpenAI. We could add matrix to this, and their frameworks where you can add matrix on the prompt, so you can actually see, what you want to, what's going on and how long it takes. But yeah, it is fast because of OpenAI. I'm sorry, that's not the best answer, but that's true.
All right. So yeah, Mike, can you put me on my slides? Oh, okay. So we're here. So now we're going to talk about the chat and memory. So what I'm going to do is I like to talk less and show you more. So I'm going to show you the demo over here. So I'm going to go directly to the demo. So over here, I think I guess you can see the code base already, but I'm going to start. So it's going to be step 2 on our project structure, which we're going to definitely share with you all. So you can go through, follow our process. So let me start this. Hopefully it works. Demo always breaks. So all right. So let me see if I can run it. Package apply. Sorry about that. Okay, so it will take some time. What's going on? So sorry about that. Demo always breaks. I think what I did is I think I know what I did is. Sorry about that. I'll be able to quickly figure it out. Okay. So what I did is I typed it wrong basically. So hopefully this will work now. Okay. So it takes a bit of time, 1 minute, I guess, to run the server if I'm starting for the first time. Yeah. So what I'm going to discuss in this step is basically the chat memory. What happens is, let me go to the over here. So what happens is, if I share my name over here, and so if I share my name, it has to remember, right? It's the API works like fire and forget. So in all the previous demo that we shared, they worked like a fire and forget. So if I go back to one of the demo that staff shared, sorry with the sound, it's doing since the morning and I'm not happy about it. So if I do this, I don't know why it can remember the previous command, but yeah, bear with me. So we have a lot of demo. I'll talk less rather than I'm going to show you the code base, how we prepared and what are the stuff in this whole code bases. So I hope from the shop you have got a good understanding of background. So all right, hopefully it ran. So if I go over here and I share my name, hello, my name is Bozlur. By the way, can you see the window? Is it better? Okay. So now if I ask the same question, do you know my name? It it will definitely say, as an AI, I don't have access to the personal data unless you shared with me during the conversation. So it doesn't remember what I just shared in your previous conversation. So this is because it doesn't have a memory of the conversation. It just fire and forget the situation. So what we can do is we can add some memory elements so that we can keep the previous conversation, and when we're going to send it the next question, we're going to attach those information along with the API. So that can be done easily over here. So we have a we pretty much described the whole things in the previous demo. I mean, Sharp did that. So we have a LangChain services over here, we have a chat model, and then we have a memory provider over here. So, and then, we have an agent. I'm going to explain this agent in a minute. But before that, as you can see, we have a chat memory provider, right? So what it does is it stores this all this information to a database, but we can also do it in memory for fun. So, there is a chat memory store over here, which is basically an persistence memory that we created, but we could have a what we say in-memory store as well, which is easily instantiable. So I'm going to show that first, and then I'm going to show you that how we can store into database so that we can keep those information. Or basically, I am a user. I come to the website, I chat a little bit, and then I went away, so that when I come back, I can continue the conversation from where I left. But if it is in memory, then it's probably not gonna do that, right? So we're gonna start with the in memory one. Then I'm gonna share with the the persistence store. So what is over here is we provided a chat memory provider, and it basically there is a API, handy API, which is message window chat memory builder. So it has a mapping with message ID. Each message has an ID that goes to the system, and then chat memory. In-memory chat memory basically it's a map, basically list of messages with ID. So for now, our ID is basically our session ID, the WebSocket that when we connect to the chatbot, we have a kind of session ID. Then we're using the session ID as a unique identifier for list of chats. So we have also a configuration over here, how many chat memory we can store for a session. I mean, we could, if we keep, thousands chat memory, then, each time we're going to send all of those chat messages to the open API, it's going to be, it will take a lot of, token, and there is a limitation to that. And Shap already explained that. So we have this configuration, and we can specify that for our particular cases. We have like 20, right? We're going to store last 20 messages. So let's start that. I'm going to start that project. So we have same here. I'm going to run it. It will take a while. I mean, a minute, and then we can show that the demo again. So it's cooking up. It's building. It takes a while. Sorry about that. So what happens is, now if I go over here, it's still not up. That's weird because it's not finished yet. Sorry about that. So if yes, now it's available. So if I maximize this, and now if I share my name, hey, this is Bozlur, and it will send me something. Hello, Bozlur, how can I assist you? I can ask, do you know my name? As you can see, it knows my name now. So the conversation now has a memory. So basically, if we have a previous chat, previous message, it will be it will be able to read that context, and you can answer that based on the context. So that's why memory. That's how we set up memory. But I showed you how to do it in memory, but we can do it in a persistent basis, basically. So what I did over here, I implemented the chat memory, interface that is basically provided by the LangChain4j, and we can just implement it. It's a pretty easy stuff. And we have a repository over here. We use an entity manager, basic entity manager that's Java JakartaEE provided. So Jakarta Persistent Entity Manager, and we just basically created all this query. When we have a chat entity over here as well. So let's see. These are the information basically we store. We store all this information in a JSON format, and we have a memory ID. And this ID basically, database ID. So I don't have to explain that. So what happens is whenever I start conversation, it will store the information, the first message, and then it keep on updating. And whenever we need to send the next conversation, it will automatically pick all this previous conversation and put them into the API so that it remember the context, where we are in. So here, probably I'm taking too much of time on this particular part, but because we don't have much time, so I'm going to swiftly move into the next demo, which is going to be about AI services, basically. So we have a I'm going to skip the next slide because we don't have a lot of time, but I'm going to talk about the AI services. Basically, it's interesting. It's basically, the idea is, we all familiar with this Spring Data JPA, right? We specify the interface, and then framework takes over and put everything. It creates a proxy on top of the interface and put everything required to make it working. So basically, it's a declarative approach. You specify, and the framework will take care of all the nitty-gritty stuff. So AI service is basically exactly that. So this is what we have been using over here. Even it is used in the previous demo, which is showed over here. So what happens is, we have created an agent over here. Let's say it's a Java agent, right? So it will take memory ID and then message over here. So so basically, we are going to talk to this Java agent whenever we send a message. So whenever we send a message, it talk to this agent, and the AI services add all sort layers, all the necessary stuff on top of it, and that's it. And along with this AI, what do we say? We can set up other information. For example, we can specify the model over here, and which I'm going to talk about which is a tool next. Okay, forget about it. We're going to talk about tools in a minute, but you can specify all this stuff. For example, chat memories, right? How many memory you can retain. So all those information. So this is basically declarative approach, and we've been using it. It's pretty easy, and I must thank for Leng4j for providing this nice API. So now that we have specified that, and let's talk about the most interesting part, which is tools. So what happens is, sometimes, have you seen that when you ask the complex question to a LLM, for example, calculation, what is the power of that particular number, or what is the prime number of that? It makes sometimes mistake, right? So what we can do is, we can help our LLM providers with the functionality. So we'll have a lot of function. We can have some functions that will basically, LLM will find out the context. So let's say this is the thing I want to do, and tools can do is, it can pass those information to our function, and our function can take over and do the calculation and put back to the LLM, and then it can do the rest. Tool is like that. It's a function, sweet functionalities. For example, we have a web tool over here. So what it does is, if I provide a URL, it just parse this text and return the text to the LLM. It's just easier. So we can specify the information. For example, returns this content of the web page of a given URL, and it will. I know how to parse the a web page, or I have a specific logic to that required by our applications, right? It LLM has their own capability, but I want to have our own capability, right? So over here, if we specify the tools to these, AI services, and we provide this information. For example, we in a human readable format, we say that return the content of the web page. If you provide a URL, then these length for change have the context of whenever user put a URL, it will give this URL to this function, and then the function can take over and parse those text. So with this idea, I have developed an interesting tool, which is called JakartaEE project tool. It's a pretty long tool, but before going into the whole context, I want to show you something. So we have a project called Start JakartaEE. So what it does is you can specify your project, right? For example, it's a Jakarta 8 or 10, and then you can specify the profile, Java EE version, and then all those things, and then it can create a project for you, right? And in fact, all of our project created by this, we started our project from this Start Jakarta EE. So it's a bundle, it's a project setup. You can then start from there. So what I'm gonna do is I'm gonna use same technique into our and put into this JakartaEE project, and I call it JakartaEE project generation tool. And I have a lot of tools over here. For example, this is a generator, right? And then we have some functionality over here. For example, and I specified all this information to the tools. For example, it's like system message, right? Generate a JakartaEE project with customer configuration, and there will be a lot of parameters I need. For example, I need the profile name, right? I need the the Java version, which has to be numerical, and then the runtime, whether we didn't need the Docker support or not. We can specify all of those as a parameter, and you can use these add p annotations. So what I'm going to do is, when I got all this information, I can build this entire project and put and provide a URL to the user. So that's what I'm going to do now quickly, because we are running out of time. So let's start that and see how it works.
So we have a lot of time. We got 8 minutes, Basler. Don't worry. So.
All right. So let's start. Okay, it takes a bit of time. Every time I switch one step to another step, I have to build the entire project. That's the downside of having this steps, but it's easier to follow. And we are planning to write a a blog post in a workshop fashion so that you can follow easily. So that's a goal. I don't know when we're gonna able to do that, but hopefully someday. So here it is. Now I can specify the URL. For example, I have two tools over here. One is web tools, and another is the generate JakartaEE. Let's say I have a website called bozlu.ca. I can specify, can you pull some information from Bozlu.ca. So what it will do is basically it will go on and whatever the information I have on the first page. For example, if I see the log, right, as you can see, it says fetching content from the URL. So what happens is this web tool is invoked, right? Because that's what we specified, and we can specify as many tools as we want with these tools. In this tool function, basically it takes a array object, so we can specify a lot of similar tools, and we have two over here. So that was in my first page, right? Now I have another tool which is basically generate JakartaEE. So I can ask, hey, can you create a JakartaEE project for me? So it says, sure. Let's start by getting some details of your JakartaEE project. See, it asks what the version of JakartaEE do you like. So I can say, what are the options do we have? What are the options do we have? So it will say, it will then provide all the option I have that I specified in this code. For example, over here, sorry, my JakartaEE tool over here. So I have like, options specified over here, JakartaEE 10, and somewhere I have I have options, somewhere over here. So it gave me the Jakarta 10 or 9. So let's go for one. Let's go for Jakarta EE 10. So now it's going to ask me the next question, which is basically, do you want to full profile or web profile, core profile? So let's go for full profile. Basically, we can keep on keep the conversation going, and it will take all this information from me, whatever we needed. So now it asks me to Java SE version. So I go for 17. So it will definitely ask me the next question, which runtime I would like to get into. So let's say I want to wildfly. By the way, that's the runtime we are running on this particular project. So now we have all this information. It asked me whether I didn't need a Docker support or not. Let's say I don't need it. And so the next question, it asked me whether I want to have the Maven group ID or all. I'm gonna say let's go for default. Go for defaults. All right, default. So now it has all this information it required. Now it's going to build the project and give me an URL, which is then I can click on and download the entire project. So that's the whole idea. That's how tool can basically simplify some of our business logic, and then along with the LLMs, so that it can be conversational. I mean, it's an extreme example. We probably gonna use the this one. It's easier, but I just wanted to give you a demo that how far we can do with this sort of tool approach with the AI services in Leng4j. So it will take some time, because as you can see, it's too busy in the over here. It's doing a lot of things because generation takes a while. This is over here, it is quicker because it does cache, and so as you can see, it says your JakartaEE project successfully generated. You can download it using the link below. So if I click on this link, as you can see, it's downloaded. So that's sort of interesting thing we can do with the AI services and tools with that provided by LangChain4j. So moving on, we can do. I mean, this is the what slides. No need. All right. So we have some slides for Retrieval Augmented Generation. I'm not sure we should go for it or not. How is the time?
I think you should definitely go for your research assistant. I think it's interesting. We can see a little bit. I don't know, Mike.
All
can
right.
we take five more minutes?
Yeah, we can go over because each of the streams are independent.
All right. So let's go for it. So so the idea is what we mean by RAG, Retrieval Augmented Generation. So LLM has some knowledge, right? But it has it doesn't know all the information, right? Because we have so many private information in our organization that LLM doesn't know. So if we want to mix some of those things, let's say I want to build a chatbot that knows some internal information as well as public information that LLM knows. So how can we provide those information to LLM to make it more accurate? Domain specific. For example, if you're a car rental shop, LLM doesn't know about your inner business things, right? About car rental. Every car rental could have been different, right? So what it can do is you have some sort of documents about your policies, your the fees and all those things, and you can embed those information with LLM, so that it can pull some of those information while giving you the more accurate results. So that's the whole idea. So over here, what I'm going to do is I have a documents over here. It's a research project. I mean, it's a paper that nobody knows yet. Um, uh, so it's recently published, and I want to embed this information to LLMs. But before that, I can ask this, about this information to the LLMs and see if it knows, right? So the research paper name is basically, using, LLMs for use case modeling. So I can ask this question to LLMs, and let's see what response it provides. Hey, do you know about this paper, right? So let's see what it returns. I think um, the WebSocket timed out, so I have to refresh it. Or did I, stop the server? I think I stopped.
You stopped the server, yeah.
Okay, so just give me a second, and I'll get back to you again.
So one
With
thing
this.
on your previous tool was I also put it in the chat though, is that when I was working with it, I was like, okay, it's giving the answers, like asking me questions about the project again and again, and I felt like this is going to be annoying for me to, just go in this process. So I asked it to do it in all in one prompt, right? And that's the beauty of the natural language processing, that was able to understand and actually execute the tools in that chain as well.
Yes,
So you can have it in
you
one
can
prompt.
put all this
Yeah.
information. Yes, you can put all this information if you know those, right? You can put all of those into the chat box, and it will understand. That's really interesting. That's beauty of it. So if I ask these questions, so it says I'm here to help Jakarta related question for topics like LLMs, and I recommend checking journal. So it doesn't know basically, right? Uh, because this one is recently published, so LLM probably not trained on this particular paper. So what we can do is we can fit this paper to the to our system, and embed those information, and then see how it works. So I'm gonna go to the next step. Um, it's probably step 5. So over here, in the step 5, what I'm going to do is, let me explain first how it works, and then I'm gonna share the demos. So over here we have a startup bean over here. So basically, when application start, this bean starts, and it sees the document location over here. It's read the documents, and then it ingests it to a busy vector. Basically, the idea is the document that we have, it will be parsed, and then it will make it vectorized. It's got something called uh, uh, sorry about it will it once it will be able to, it will make the document, it will parse the document, and then it will make a vectorized format, and then it will store in our local pg vector. And then when we're gonna write a prompt, it will search this information if these are available in our local database. If find the content, it will add those content to the user prompt, right? And then so that it will reply based on this result. So it will be more natural. So there are various ways to do that. We have over here a embedding model. So the idea is we use some sort of embedding models to embed those information. And one of the embedding model is all mini LM652. So this is one of the dense I think dense model, right? There are few other options, but this has a larger dimensions. So basically, it very appropriate for when we have a text documents. So
I think if I may add, Basra, is that this is also local, right? So we're not using the
yes,
OpenAI ADA embedding here. We're using a local model instead.
right.
And LangChain for J can handle both. So that's quite nice.
Yes, so we can send our OpenAI to do all these embeddings and return those results and store in our local database, or we can also do locally. It supports both, right? So it's really interesting. All right. So what happens over here? Let's go to the LinkedIn our startup pin. So what we do is we have a document, and then we convert those documents into a certain segments, and we embed those within embedding models, and we store that in an embedding store, right? And next time when we're gonna put a user prompt into chat box, it will search. It will find the similarities of content available in this looker. It's something called semantics search, right, Shaf?
Yep, that's correct. Yep.
Right. So basically, why it's called React, because so basically we store those information in our local database, and we retrieve those information and add that to the context, add to the prompt. So let's see the example over here. So we did few things over here. First of all, we have a PZ vector embedding store. It's available by the LangChain for J library, and we use that. And we have a setup over here. It's use the local database. We provided all this information required. For example, data source, right? And we also have an embedding model over here, and the startup pin. What it does, it's first checks we have already information available, because we're going to keep on restarting the service. So if we don't want to store every time we restart the information, so this is what it does, is basically it looks if we have already same documents over here. Not necessarily, it's for demo, not necessarily in your production system you're going to do the same. So it looks like that. Embedding store looks like that. It has an embedding ID. It has the embedding, which is the vector space, multi-dimensional, which is basically some numeric value. I definitely don't want to bore with those things, and then there is a text basically. So moving on, and then basically it's parse the document. We have a fine, we have some classes API available. For example, file document loader has a load document. So basically, if you specify a directory, whatever document in this directory, it will load them, and then and then there is a document parser. So we are using the Apache Tika document parser. There's multiple document parsers available over here. Actually two, but we can implement our own parser as well, because it's just the interface, right? So this is the text document parser, simple, but there is another one which is it quite performant, because we have a PDF document, right? It can contain emails and all sort of things, right? So it takes all this into considerations. So all right. So now we have all these document, and then we filter, and then we convert them into a text segment, and then we use the embedding model to create an embedding, and then we store those into our PZ factory store. So let's start that and see if now it can find these informations that it can answer the same. It can answer the same question that we asked previously, which is this: do you know about this LLM? This paper basically. So let's see if it can. So it will take some time, because it's going to run first time, and it will parse these documents, and as you can see, it's parsing a lot of logs over here. Once it is done, if I see the database now, I'll be able to see a entry in the database, which is this, and it has all these embeddings, and so now if I go over here and ask the same questions, and let's see if it can answer that. So I'm going to ask these questions. Yes, it looks like it can answer these questions, and it finds all this information over here related to the documents, that it formatted in a way that's basically it summarized all things. So that's interesting, and we can ask a specific question about this paper. For example, what were the research questions? So now it can find specific information about research question. For example, there were 4 research questions in this particular paper, so it can find those information. But this is not available in the LLM, in the ChatGPT. If you go to the ChatGPT and ask the same question, you will not be able to find it. So these are locally sourced, right? So we can embed those information to our LLMs, and then LLMs can inform, it can answer more accurately with this help of local embedding. So that's basically what is RAG. And we have more examples, but I don't think we have time, but I can go over quickly. For example, so this is the LLM provides 3 types of RAG. One is easy, which is I used in this demo, and there is called naive, and then there is called advanced. So you can keep on enhancing and enhancing. You can also, for example, what happens over here is in this documents, it's a whole documents, right? If we have a lot of content, for example, the PDF can be large, right? We have a different set of documents. For example, it can have paragraphs, it can have question and answer session, right? For example, a document with a QA, right? So the textual data can be different. So we want to make it performant in a way. We don't want to put everything in one go, right? That will use more tokens, and it will be costly and less performant. So what we want to do is we want to split the documents in a way so that it only takes. So whenever we write a question, it will take the questions and it will search in all these splitted embedding and find the specific one. And the token size will be shorter. That way, it will be more performant and it will cost us less, right? So we can split this document into multiple ways. For example, we can split this document into part documents. We can split the part chapter. We can even do in part sentences. So it depends. Part document is suitable for large retrievals, where each document is treated as a unit. Part chapter is where useful, when structured document like books, reports, where chapter represents a distinct section, and sentence is useful when we want to get a fine-grained question answer or summarization, something like that. So there's a different way of splitting that, and the section 6 actually work on that, and the same structure. But we have a different settings for startup pin over here. So what we did over here is, first of all, we load the documents, and we will filter out the documents that already exist, and then we provided a splitter. So in our case, we provided a document by paragraph splitters, but we have also other options. For example, like I said, part documents, part chapters, and part sentences. And then in these splitters, we can provide the segment size of token, right? How we are going to split it, and if do we need any overlap. So those are the settings we can provide here, and we did that over here through this configuration. So it's depend on efficiency basically, and how. For example, if we're using ChatGPT, we might aim for like the max segmented size is 4,000, and overlap is basically, the idea is, let's say we have segmented the documents, and we keep on the continuity. So there will be some overlap. Ideally, 10 to 20% overlap is good to avoid losing context. Otherwise, if it's a continuous document and we keep on splitting, it can split a sentence in a way that doesn't make any sense, right? So that's why overlapping is important. So what we did is we provided a splitter, and then there is a store ingester builder. It's a nice API, so you can provide everything in a builder pattern way. So we provide the document splitter, and then we provide the embedding model, and then we provide the embedding stores, and then finally we call this ingest token. So we basically created a pipeline, and we specified everything, and when application is going to start, it will do all these things. So if I remove this now, let's say I remove this, and I'm going to start the step 6 again. Sorry. This step. So we have so many back and forth. That's a problem. But also, I think it's going to be useful when you're going to look at the source code in one place. So now, if I start this, what it's going to do, it will take some time, because it's going to, start the application and then, do this parsing and then splitting and all those things. So if I now see the embedding store, okay, it's doing now. It hasn't completed yet. So if I see, as you can see, the same document, initially it was like one document. Now it has split it into these 16 part. So now if I ask the specific question, it will first go on and try to find the similarities over here, based on these embeddings, and it will be much more efficient and what do we say, perfect and less costly, because we're not gonna expend a lot of it will not cost a lot of tokens, to be honest. So that's also less make less costly. So yeah, I'm gonna ask the same question about over here, and let's see what happens. So if I ask the same question over here, so it knows, but and then we can ask the next question, which is basically what are the research questions. So it will give me the research questions same way, and we can go specific. We can ask more specific questions. For example, what are the qualitative quantitative results of question 1. So we can go in deep and specific questions. It's quantitative. So and then it knows the question, which the question 1, right? It has all this context. By the way, it has also required the memory to keep the context. So that's the demo so far. Hopefully you have enjoyed, and let's take some questions, I think. I guess.
Yeah, I don't see any questions, at the moment. So this is everyone's last chance to do that now. So I want to say that, and Shaf, you heard this yesterday. I attended a webinar on AI sometime last year, and I typed in my name, and it generated an image, a caricature of a very young man with a lot of hair, and I'm like, yeah, I like AI. So let's keep on doing that.
So. Yeah, it sometimes hallucinates, Michael.
Hey, Mike, can you share the screen again? So we have.
What's that?
Can you share the screen again?
Yeah. There we go.
Okay.
Yeah. I think it went off automatically. Yeah. There we go.
All right. So let's take some questions, and I would like to, thank you everyone who are here, and if you have questions related to what we have demoed and what we have, shared with you, that would be awesome. And yeah,
Yeah, no one's taken advantage of it. I know there's a handful of folks still with us here, so thank you for that. While we're waiting, real quick, since this is the last day, I want to thank Ken Fogel, of course, who is the main driving force behind this conference. There's also roughly a dozen of the other Java champions that are on the committees that help organize. I know Basler, yourself, I think you were the CFP organizer, right? So thank you for your time with that. I was on one of the committees last year, but I was honored to have had my talk selected for this year's event. So
by the way, I didn't vote for my talk. So just to be clear, that I didn't take the advantage of being a safety organizer. So basically, I voted everyone else's talk, but not mine, so that it's fair.
It's all good. Let's see. So we have here, is the code from the demo publicly available? This is from Victor.
Yes. As you can see, in this last slide that we're sharing, there's a link over here.
Okay.
I can share this link in the chat as well if you want.
I just shared it.
Perfect.
Yeah, I shared the link. The code is available on Git, and we are looking at making a workshop, like Basler mentioned. And we are also, we can say this, we are in process of writing a book about these topics as well. So stay tuned.
All right. So
I look forward to that, by the way. So I'm God as asking a question. When will we see Java dominating LLM development? That's a good question.
When the answer is when you start working on it.
You took the words out of my mouth, Basler. Exactly. The day you start developing, it's
that's right. It's, open source is everybody's invited to contribute. So that's a good answer. So yeah. So I guess that's it. No one else. Again, thank you all for spending all the last 4 days with us. Yeah, go ahead.
Here are all the links available. If you want to reach out to us, you can reach out to us through our Blue Sky, X.com, our website, and you can reach that would be awesome. If you have any questions, feedbacks, and also since we are working on this topic and we will be working on this time probably, so anything you want to share, that would be awesome. Like Shaf mentioned, we're working on a book on this topic. So yeah, any feedback, anything you would like to add, or while you were exploring the demo, if you say anything, you can always raise a pull request, and we can definitely look into it, and we can learn from you. Personally, I'm learning. I'm still learning. I'm learning from Shaf and everyone else in the so yeah, the most important thing is it's a learning experience, and I love to learn new things. Yeah. So that's the thing.
Yeah, I'd like to wrap. I'd like to work with AI some more myself. I understand the concepts. I've seen enough, but yeah, just there's a lot of good out there with that. So I look forward to seeing more.
All right. Take care.
So with that, folks, thanks again. There are 2 more sessions, the 2 o'clock hour and the 3 o'clock hour. And we'll hope to see everyone at conferences or other online events. So take care now.
Take care. Bye-bye.
Thank you.